Okay, our first opening question. A bowling ball is in equilibrium. Win it. And we had
both the above
for our answers. And once again, we're going to hope that we can make it right. Oh, see there. You can see I was trying to write. 3 said at rest. And 2 said both of the above. Now, what we learned, okay, equilibrium. I just said what equilibrium was. The net force is 0. The sum of all the forces add up to 0. Newton's first law is known as the law of equilibrium, or the law of inertia. I should say law of inertia. I didn't mean equilibrium. The law of inertia.
Inertia.
And Newton's first law, if you say it in words, is an object in motion stays in motion unless a net force acts on it. So a net force acts on it means the net force is not 0. So what it really says is if it's in equilibrium, if the net force is 0, then it will stay in constant motion. So it's kind of simple. It's saying equilibrium, so equilibrium equates to constant motion. So is at rest constant motion?
No. Yes.
Yes.
Sorry, yes. Yeah.
At rest means the motion is constant at 0.
So is B.
But so is B. Moving steadily in a straight line is also constant motion.
This is why I can't take tests. I change my answer every time.
So what's not constant motion? Since both of the answer is C, they're both correct. What is not constant motion?
Zigzag lines.
Okay, zigzag lines. If you change direction, it's not constant motion. She said circle. Again, changing direction. Also, if you speed up or slow down, that's not constant. So changing direction or speeding up or slowing down, all of those would be not constant motion and hence not in equilibrium. So now I'm going to list some forces. We've already talked about gravitational force. What direction did we say the force of gravity was on me?
Down.
Down. The force of gravity is down. It's a vector with a direction. The force of gravity we talked about last class period, what it depends on. What's the force of gravity depend on?
What?
What makes the force of gravity on me different than the force of gravity on you?
Our weight.
Weight is the name for force of gravity.
Or the force.
Mass. Because remember this from last lecture, the force of gravity is equal to mass multiplied by the acceleration of gravity.
Are we going to have, I'm just curious, on your test, are we going to have essay or is it just all?
No, we will not.
Oh,
They'll all be multiple choice or true false. Translation, they're all going to be graded real quick. So force of gravity is mg. Now I know this says support force and I haven't talked about support force at all, but I will. But it has direction. We indicate in physics writing, the way we do math, we indicate direction when we put an arrow over a variable. So force has direction, so I put an arrow over it. Mass does not have a direction. Mass we call a scalar quantity. Scalar meaning no direction. It still has a magnitude. For instance, a person's mass might be 75. What are the units of mass?
Huh?
What are the units of mass? Kilograms. Now, when we talk about weight, we often talk about pounds, right? Pounds is not the metric unit. What was the metric unit?
Meters? No, wait, no, what? For what?
The metric unit for force or weight. Or not the metric unit.
Newtons?
Newtons is the metric unit, right. So if there's a difference in the imperial unit of pounds and the metric unit of newtons, then there should be some equivalence to the mass metric unit of kilograms, and there must be an imperial unit. And this imperial unit I exemplify very well. The imperial unit for mass is slugs.
Slugs?
So I have a mass of some amount of slugs.
Like, interesting.
Of course, slug is probably talking about, a slug like an ingot. But I think of it like the University of California at Santa Cruz banana slugs. That's the mascot.
Oh, I was thinking of a gun.
Really?
Yeah.
You put slugs in a gun.
I grew up there at Monterey Bay Academy, and that was local. So mass in kilograms here, but it has no direction. G, which is the acceleration of gravity, and something we're going to focus on later in this lecture, has a direction. But if you read this equation, it's true not only for magnitudes, but also directions. So the magnitude of the right side, that is the mass times the size of the acceleration, is equal to the force, but also directionally. So the vector on the right-hand side, that's G with an arrow over it. The arrow says it's a vector, it says it has direction. If the force is down, G must be down because the directions have to match too. So why am I talking about this on a slide that says support force?
No idea.
Well, the first law says that an object stays in constant motion unless a net force acts on it. Now I'm standing here and I'm telling you gravity is acting on me. I can feel it.
Yes.
But I am in constant motion, am I not?
Yes.
I mean, yeah.
Right, I'm not speeding up, slowing down, changing
You're
directions.
definitely constant motion.
So how is it possible that I have a force acting on me and I'm in constant motion?
Because
Support
gravity is
force.
pulling.
Gravity's pulling, but there must be, and of course, whether she knew it or not, she knew that was the topic of the slide. There's a support force. There's a second force acting on me, not just gravity. Sometimes you'll see people write Newton's second law incorrectly, and I'll get to that. But there is an upward force acting on me. There has to be, otherwise I'd be falling through the floor. And so we call that force, our textbook calls it a support force. Nowhere else in physics do we call it a support force. We call it a normal force. Now here's the reason the textbook calls it a support
It
force.
supports.
It supports.
Yes.
Normal does not mean what you think it means. So with that said, what do you think normal means?
Normal force is a force.
That's something that's always there, regardless of situation.
Okay, that's what you would think it means, but it's not what it actually means. Normal is a direction. Normal means coming out of the surface. So the normal force is the force coming out of the floor to keep me from falling through it. And it'll be whatever is necessary until we reach the ultimate strength of the floor and it breaks. But it's coming directly out of the floor, so since the floor is horizontal, directly out of it is vertical. But we could go to the wall here. If I push my fist on the wall, it's not going through the wall. But I'm pushing that direction. What's keeping my fist from going that direction?
The wall.
The wall is providing a normal force, a force that is coming directly out of the wall.
Okay.
So it's coming this direction.
Right.
So whether you say normal force or support force,
Same.
it's important that you know it's going to be the force necessary to keep something from going through a surface and it's coming directly out of that surface.
So the floor is putting support force on you.
Yep, to keep it from falling through it.
Oh, that's great.
Yeah, it's a good thing, right?
Yeah.
I'm glad it is. And if I were heavy enough, I would break the floor and then, well, I would lose that force.
Very unfortunate.
And your job.
Well, I mean, they can't fire you just for
Does
being
that mean, like,
heavy
the
enough to break
ground-
floors, can they?
Does that mean like the ground itself, like there's a force from within?
When you step on it, you're compressing things underneath, and they're pushing back, keeping you from falling to the center of the earth.
Okay, cool. That's what I like to know.
Okay, so here's a question. This is a real question, okay? My brother, before he had bariatric surgery, he weighed, what was it? 465 pounds. And you know what you can't do? You can't go to Walmart and buy a scale that will measure your weight. But before he could have bariatric surgery, he had to have, how much do you weigh? And psychology, counseling, and a bunch of things. And so he was like, I'm no idiot. And he went to the store and he bought 2 scales.
Huh.
And so you can start answering now. When you stand on 2 bathroom scales with 1 foot on each scale and weight evenly distributed, so you have the same reading on both of the scales. You're not leaning to the left or leaning to the right. How much will each scale read? And we have a collection of answers. 4 out of 5 have answered. Vanessa's all, it's not me this time. Should I wait or should I go on? Well, since you all believe you answered, I'm going to go on. It still says only 4 or 5 have answered, but you know, what's the point of everybody saying I did and waiting, right? So what we had was one person said A, 2 people said B, 0 people said C, and 1 person said D. We asked these questions because, of course, I haven't said any words to answer this particularly, right? But I've covered the concept, and now we can see how we can apply that concept to get the answer. So, first thing, because it's the topic of the moment, the gentleman standing on the scale, we pretend he's my brother, is he or is he not in equilibrium?
He is.
He is. So if he's in equilibrium, what does that imply based on Newton's first law?
That there's nothing acting upon him, so he's just going to stay.
Not that there's nothing, but that the total
is zero.
The total is 0. Nothing acting on you and the total is 0 are 2 different things. Nothing acting on you is the case that Vanessa's been talking about when you're out in space with nothing nearby for gravity and no atmosphere. That's nothing acting on you. We're never in that situation, but we can still be in equilibrium with everything adding to 0. So he's in equilibrium, everything adds to 0. Now, to answer questions like this, we in physics draw diagrams. We call them free body diagrams. I'm going to add to it. We draw a diagram showing the forces. So what forces would be acting on my brother?
Gravity.
Gravity. What direction?
Down.
Okay, we are nailing this. So there's his force of gravity.
Normal force.
Normal force, but now he has 1 foot on each of the scales.
2 normal forces.
So 2 normal forces.
Normal force squared.
Force normal 1,
Plus force normal 2.
force normal 2.
So squared.
Yeah.
And now we just apply what is the total force.
I don't know how much this is.
Anybody know what that symbol is?
That's a sideways M.
Or a W.
Or backwards.
It's Greek. It's a cap.
For beta. For
It's a capital Greek S.
Kappa.
It's a capital S, and it stands for sum.
Sigma. Oh.
Yeah, sigma.
Oh, really?
Yeah.
Oh, wow, that was a. I was like, yes.
So that stands for sum. And so in physics, we use this kind of math nomenclature. So we put sigma F.
Are we going to need to know this?
Yeah, you'll need to know it.
And the F and the little thing on top of it, remind me again what that is? Wait.
That's an arrow, and that means
Wait.
means we have direction.
Oh, yes, but you had a name for it.
Well, when we did it over here, we had force of gravity, so that's why it was weight. But here it doesn't have subscript. It's just adding up all the
Oh,
forces.
it's just an arrow.
Another way we can write this is equal to
Sigma force.
force with the subscript of net, because net means you added them all up.
Okay, cool.
The vector sign has direction. So if I look at my picture, well, first of all, Newton's first law, if it's in equilibrium, that's equal to 0.
Yes.
So in this condition, it is in equilibrium. So let's just look at the forces. We have forces all in the vertical direction.
Yes.
So I'm going to sign up as the positive direction. So if I add up all the forces, I have 3 forces in my diagram. The reason we make this free body diagram is so we can add the forces up correctly.
Right.
So I have 3, 2 of them are up, so those I'm going to call positive. So the sum of the force vectors is going to be, and notice it's one-dimensional. Everything is vertical. So I actually am going to drop the vector sign now because they're all in one direction.
So you don't say up and then
No, go ahead, Annabelle.
no, it's okay. I answered it.
Good.
In my head.
Okay.
Well, it was just like you don't say sigma. Is sigma and sum the same?
Sigma and sum of are the same thing, yes.
Oh, okay. That's what I thought.
So the sum of the forces is going to be force normal 1 plus force normal 2 plus, because those were pointing the same direction that I defined as positive.
And that's why you didn't put an arrow.
And that I didn't put the arrow because they're
going
all
the same
vertical.
direction.
And then minus the force of gravity, and that's going to equal 0.
Right.
But we had a condition here that the weight is evenly distributed.
Well, what's his weight?
Well, we don't know. We don't care in this case.
Oh, okay.
But what matters is that means that force normal 1 is equal to force normal 2 because it's even.
Yeah.
And so I'm just going to call these force normal and get rid of the 1 and 2. And so that gives me 2 force normal
Do you know how hard it is to type this?
equals force of gravity.
I think
No, I don't.
It is quite confusing, man.
I'm sorry.
you were like pulling them.
I mean, I got it, but
Are you using Microsoft Office?
no.
Oh.
I'm using Google. I mean, the Google has symbols. I'm just curious. I'm like, so do we need to know that EF equals FN plus FN minus FB equals 0?
I
Okay,
think it's just
that's a summation. I know my summation is sloppy.
We just need to know the symbols, like what they mean.
I'm applying this equation that's in red
Question.
in purple. So purple is the application, red is the equation I'm using.
Question.
Annabelle.
G is gravity, so force
Yes.
gravity.
Yes.
Fn is force Newton because Newton is the thing.
Normal.
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 Oh.
Or support, as our textbook calls it.
Right.
It still uses N for it because it's the normal force.
Right. I understand.
Okay, so what do I have here?
You have numbers.
I have 2 force normal is equal to force of gravity,
Yes.
which means force normal is equal
Wait,
to how
so
big?
why did it take you that long to get there when you could have just?
Because I'm trying to make sure you can get there.
Oh.
I would have done it like that.
I
But
mean, because it's pretty obvious. FN1, FN2, 2
Mhm.
FN.
Yeah.
Yeah. Okay.
But you have to have a framework to see why it works out and not just because what seems obvious in one situation, you go to a harder problem, you're like, but you use the same ideas.
I get it.
So we're not
Oh,
going to
Justin.
have questions like this on the test, are we?
You certainly could, yeah.
Oh, okay.
But I think don't worry, I think
Don't worry, Annabelle will get them
I
right.
understand. You're gonna see this paper slowly floating over here.
No, we won't.
No, I understand. I was
Good.
That is a good thing. Working together. Remember, I said that for homework. Working together helps everyone. So, final step here, divide both sides by 2. And we have the force normal is equal to force of gravity over 2. So, which was the correct answer?
What?
FG over 2.
I truly have no idea.
Which is A, B, C, or D?
D.
Oh, D. B. It's B.
Okay.
I don't know. I just screamed out a letter.
It's B. It's B. It's B.
Half of the weight on each one. So, all we had to do with my brother was add up the 2 scales. And I'm a physics professor, and even at that point, I've been a physics professor for 7 years.
This is like math.
But I still had to think about it because it was like, okay, real life, how do we do this? And of course, I figured it out, but I don't expect you to be any quicker, like you just see it and know the answer. You have to think about things.
Yeah, because we did that.
There's 2 FNs,
Right.
and then there's 1 FG. So what you do is divide by 2. It's kind of like a math equation. You make it equal.
Oh, okay.
And so FN equals FG half. So it's half of your weight.
Okay, that makes sense.
Because the gravity, weight, mass. Okay, yes.
All right.
Thank you.
Excellent. Moving forward then, maybe.
I feel really smart.
Another force,
You are.
the force of friction. On our first day, right off the bat,
Yes.
Jessica invoked
Jessica.
friction.
Good job, Jessica.
We all have at least an idea of friction. Friction is a force that happens between 2 surfaces to try to oppose sliding. Now, we actually break friction down into 2 parts. You can have kinetic friction, which is they're actually sliding and it's opposing it. Or you can have static friction, which is it wants to slide, but the friction isn't letting it.
It wants to slide.
Yeah, so for instance, if I take this,
Oh, I get what you're saying. Keep going.
it wants to slide down,
But
friction is keeping it from sliding down. So this is what we call static friction.
Static.
Whereas if I raise it more, it slid. There was still friction, so it
That's
slowed
not
it down. That was kinetic. So kinetic means in motion.
Static means still.
Static means still.
So static force friction is equilibrium? Oh, no, because they both are. No, not
I'm not going to go into that right now because there are situations like you have a bag of sand sitting in the back of your pickup and your pickup accelerates.
Yes.
The bag of sand is accelerating, so it's not in equilibrium. But it's also not sliding.
Okay, so static is,
Static is when the
means when it's
surfaces
still.
are not sliding
Yeah,
against
so like
each other.
it's at it.
and
It's
the other one was,
Kinetic, which means the surfaces are
Moving.
moving against each other.
still and moving. Good job.
But remember, it's with respect to the surface. This goes back to what Vanessa was saying about reference points. You know, if this is here and this is here and they're not moving with respect to each other, we say that's static. Even though they could be going like this and they're both moving. So, friction, something that's trying to oppose sliding. Friction always acts in the direction to oppose motion. So right now, what direction does this mass want to slide?
That way.
Now I say want, of course I'm anthropomorphizing the mass.
Yeah,
but
it's that
it
way.
wants to go that way, so what direction is friction
Well,
going?
gravity's making you go that way.
Right, gravity, and that's kind of a complex thought that we'll get to later on how gravity, which is down, is making it trying to go that way, right?
Wow.
But gravity is making it so it wants to slide this way, so what
Yes.
direction is friction going to have to point to oppose motion?
upward.
Upward, right. So friction is pointing up. Now, if it slides, the directional analysis is easier. If it slides, the force of friction is always opposing the direction it's sliding. So if I put a violent motion on this and make it slide upward, what direction will the force of friction be acting?
Oh, that way.
Right, because it will be opposing the motion.
So it's always opposite.
For kinetic friction, it's always opposite the motion. For static, it's opposite the direction it wants to go. Because it's not actually sliding.
Opposite direction. For static.
What causes friction is actually an interesting
No,
thing.
this. Sorry, say that one more time.
So what causes friction is an interesting thing.
Okay.
There are, believe it or not, forces strong enough to make actually a bonding between this metal and this wood.
Glue.
No, I mean right now. Without
I said glue.
glue would certainly make it stronger. But there are,
Is that not static friction?
it's what's causing.
Oh.
Now there are other things as well. Like if you take my fingers as my example. If I put my fingers like this,
Yes.
they won't slide against each other because they're kind of fitting together.
Mhm.
You also have that going on with friction. Now, if it's static friction, you have both of those. But if it's kinetic, once it starts sliding, it actually has to rise up and it mostly is staying up. So,
I'm really confused.
kinetic, okay, so static friction, my fingers fit down in between each other.
Uh-huh.
But if it's
Still.
kinetic friction, they're sliding
Right,
over each
right.
other.
Movement.
And it will drop a little between, but
Not a lot.
it's not such nice even striations here. So in a reality situation, it'll just stay pretty much the same height and you won't have that matchup occurring.
Okay.
So that means the static friction is actually bigger than kinetic
Oh.
because you have
It's
to
stronger?
overcome both the bonds and the little fitting together.
It's stronger.
It is.
Oh. Very interesting.
So yes, that's why I go through it. It's interesting. I mean, let's be honest. I find all of physics really interesting.
Yes, clear.
Oddly, that's why I went into it, right? And I know you guys aren't as excited about it as I am.
Oh, you're not wrong.
But I'm getting there
Okay,
slowly,
slowly.
but it's going.
Okay, yet another question here. Here we have Nellie. And Nellie is pushing a box across the factory floor at constant speed. Think about what constant speed means. The force of friction between the crate and the floor is, and we have some questions we want to answer. Which one is right?
Wait, the floor and the crate.
Yes.
Wait, the force of friction between the crate and the floor.
Because it's static, so it's more. Because it's stronger.
Static is
Because
still,
I want
so
no.
I'll explain after you answer. I want you to think about it and answer to the best of your ability.
Okay, I'm
Oh, we have to answer on the thing?
Yeah.
Yeah.
Oh my gosh, that's stressing me out.
Well, I don't even know what you answered, so you shouldn't feel stressed.
Well, I'm stressed because I know what I answered.
And in case you're wondering about the pedagogy here, the pedagogy is forcing you to actually decide what you think is most likely instead of saying, I don't know, he'll explain it. Because
Sorry, you just brought in a new vocabulary term that I was not aware of.
Pedagogy?
Yes.
Pedagogy is okay, now I'm going to give you a bad definition, but it's the teaching method and the reason why.
Did you already close the voting in order?
Yeah, it closes after a minute, so it's closed. Here, I opened it again.
Oh, okay, that's probably why you only had 4 answers the last.
No, I had reopened it.
Oh, okay.
Although it could be the person hit their answer when it was closed and they were like, hey, I hit the answer. Okay, so with the pedagogy, the reason is if you're forced to put an answer down, it doesn't matter what your answer is because you had to actually think, I think this is the most likely answer and go through what you did understand. And then when you are confronted with the actual answer, either it reaffirms, yes, I understood, or you have that little cognitive dissonance of, I didn't understand, what did I have wrong? And you can correct things that you didn't have right.
Cool.
So,
what's the answer?
As future teachers, you should have reasons for everything you do in class and not just, that's what we do.
This is true.
Okay, so what is the answer? Right? Talking about teaching pedagogy in a class for education majors is important. Okay, so the correct answer, it is equal and opposite to Nellie's push.
Dang it.
Now, the reason why, and we had 3 people who said that, 1 who said the first 2. I put a box around constant speed. What does constant speed mean to you?
Dang it, no, duh.
What does constant speed mean to you?
That is equilibrium, and it's also kinetic.
Static.
Okay, so we've got a couple ideas.
Oh.
We have a couple ideas.
Yes.
And I should have said it's in a straight line because if she was going to circle, it wouldn't be equilibrium. but she's going in a straight line. So constant speed in a straight line means equilibrium. So that was the first thing, recognizing it's equilibrium. So if it's equilibrium, we learned that the net force has to be 0.
Yes.
Now, if we look at this picture, what forces are acting on the box?
Kinetic.
Kinetic what?
Kinetic force.
Kinetic friction.
Kinetic friction, sorry.
So we have a force of kinetic friction, and what direction is that force going to be pointing?
Opposite.
Opposite to the direction it's sliding. So since the box is sliding to the right, we're going to have the force of kinetic friction pointing to the left. You notice I always use F to indicate a force.
Yeah.
I don't write out the word force because I'm, like all physicists, lazy.
Okay, question. So what if you want to put friction?
That's what the F, the lowercase f there, the subscript is.
Oh.
So the subscript is telling you what kind of force it is.
Okay.
So Kf for kinetic friction. Now, simple rules. Your symbols are your own.
Kinetic friction?
Yeah, the sliding friction versus the static friction.
Oh, you mean kinetic is
Much like Bob Ross would say, it's your painting. You do with it what you want. The symbols are your symbols. Nobody cares fundamentally what symbols you use as long as you can work out a problem. And so I choose the ones that work for me, and you can choose different ones.
Yeah, kinetic.
No,
sorry, we had it.
We had it spelled wrong.
Oh,
Yeah, that's
okay.
why I was like K.
Kinetic, K-I-N-E-T-I-C.
We had it spelled with a C.
Okay.
Kinetic. Oh my gosh, that looks
So-
familiar.
Yeah, right.
I get it.
So we have the force of kinetic friction. What other forces do we have?
Static.
Yep.
Oh, on this one? Oh.
In this problem.
Gravity.
Okay, we have the force of gravity. What direction?
Down.
Now, it's good that I'm writing with a stylus because I almost did something I have done before with an actual marker.
Oh, and then we have
I
normal
almost
force.
went up here to
Normal
mark.
force.
We have the normal force. We are really getting there. Force normal. And then there's one more force here.
Oh my gosh, another one? Oh, hers.
Yeah, the obvious one, hers. So we have,
Oh my gosh, you're matching her dress.
yeah, that's a bad choice
Oh.
because it's harder to see. The force, and I'm going to put P for push. Right? I said it's your choice what symbols you use. You might want to put F sub n for Nelly, but we already have F sub n for normal. So I chose P for push.
person.
Person, okay.
Yeah. But what if it's not a person? I mean, most of the time.
It's a person.
Okay.
Now, it's an equilibrium, and what does equilibrium mean?
Constant.
Equal.
Equal or constant? Motion.
Okay, constant motion or equal
Friction.
forces. So
You're so close, girl. You're
Sorry.
so close.
notice in this case, our forces are not all in one direction.
Yes.
Some are vertical, some are horizontal. And in that case, we do them separately because they have to add up to 0. And the amounts you push this direction have to add to 0, and the amounts you push this direction have to add to 0. Otherwise, you go that way if these didn't, or that way if these didn't. So we generally just put X and Y to indicate the directions. And then I'm going to put sum of the forces in the X direction equals 0. Looking at my picture, since my X is positive to the right when I drew that little thing and put an arrow to the right, that means that's positive direction. Then I'm going to have the force of the person minus the force of kinetic friction equals 0. And therefore, force of the person equals force of kinetic friction.
But one could argue that it's almost impossible for a person to be in constant speed.
One could make that argument, but in physics class, we just say it's true.
I don't like it.
Now,
We're in philosophy class and we are learning that we should never just assume anything is true. We should have a fact.
I will assume that's correct.
Come on.
Okay, I think I'm funny.
Okay, sorry.
And Annabelle was saying now we should do the Y direction as well.
Yes.
And if we do the Y direction, I'm going to have sum of the forces in the Y equals 0.
To 0.
And so which one is in the
G.
positive direction?
Oh, Fn.
Okay.
Fn is equal, minus Fg is
Okay.
equal to 0, right?
I'm writing the wrong spot on my screen.
Oh no.
Yeah. Fn
Is
minus Fg.
is equal to 0, so Fn equals Fg.
Anybody know what those 3 dots mean?
A
Etc.
triangle. So therefore.
That's right. Therefore.
Oh, really?
Yeah.
I'm a genius.
Why are you even in college?
So she can exert her genius.
Keep going.
Show people. Okay, so there we have our answer. We had equal in magnitude based on the math there. Opposite in direction, we determined that from our picture. So you put those two together, they're equal in magnitude, opposite in direction. Okay, acceleration. Acceleration, do you remember from lab yesterday when I defined acceleration? Oh, I didn't define it, did I?
No, you didn't.
I defined speed. What was speed?
Speed is a motion. I have no idea.
Another word for point. What?
Oh, direction over wait. Oh, direction traveled over
Distance.
Oh, distance traveled over time spent. Time
Yeah, spent is fine.
elapsed.
Now, in physics, you do remember I said a moment ago that we're lazy.
Yes.
You are
We do not like to write out the word speed.
You are correct.
So we do S.
You would wish we did.
Oh.
We use V.
V. That's velocity.
Yeah.
That's what it is.
Who came up with these? Because we need to have a talk.
Yeah.
Yeah, we need to have a serious sit down. So if we convert this into equation form, normally how we write it, we put, they're not the same, but they're related.
No.
Keyword.
So let's look at the difference in velocity and speed, because the V does come from velocity. Velocity is speed with direction.
Well, velocity is the V with the D.
Velocity is speed with direction.
Yes, because it's a V. Speed is V, and distance is D.
Okay. So what do we call something that has a size, the speed is the size,
Whatever.
and a direction?
Huh?
What do we call something that has a size and a direction? Both things.
Why are you looking at me? You don't get the.
I got it.
I know you. Yeah, I'm sorry. I'm focused on science.
What do we call something with both a magnitude, a size, and a direction?
I literally have no idea.
Okay, it was a vector.
Oh.
Vectors are things that have a size and a direction. So velocity is a vector. And this is how we write velocity. So V with an arrow over it is velocity. It's speed with direction. Without the arrow over it, it's just speed because it doesn't have the direction.
Unacceptable.
No. Yeah. Oh, I got it.
By the way, because we only have 2 minutes left, you guys have been working on your questions. It looks like everyone has a question already. Nice. Okay, so V is speed. Then we have distance traveled. We traditionally use X for position. In one dimension, if you have 2 dimensions, you use X and Y like I did in the last problem. And we use that. I know it's a triangle, but it's a Greek capital letter again. Delta. That's a Greek delta, capital delta. And that means change in.
B with the arrows velocity. B
Yes.
right along with speed.
A lot of symbols here, huh?
Yeah.
Yeah.
I'm seeing that.
So delta is change in. Distance is change in position. Time elapsed is change in time.
Oh, wow. You're really going way too fast.
And
Like, I was at a level, but then my level has decreased.
I think you're okay, actually. It's going to take a while to sink in.
You're not worried about you.
But speed is
You are on.
change in position over change in time, and that's what V equals delta X over delta T means. So one of the things you need to know is what that delta means. And it's always final minus initial.
Do we have homework?
It's due next Wednesday.
On little.
The homework 01? What?
Yeah.
That's it.
Exactly.
I already did
We don't have a class between now and then, though.
Oh, pets.
Well, I did so.
Nice.
I already did it. Yeah. I did it the day it was a
Somebody is good student. All right.
That is not a good, healthy coping mechanism teaching skill right there. You should never compare your students.
I didn't say anyone was a bad student. I said somebody was a good student.
Else just assume wonderful.
Everyone else could be a good student too. I didn't.
You're